So a basic question would be something like number 33. So you want to find the line through the point 3 minus 2 with slope 3. So one way to do it is the following. You can say the standard equation for a line is y equals mx plus b, where m is the slope and b is the y-intercept. And we're told the slope is 3, so y is equal to 3x plus b. And we're also told the line passes through the point 3 minus 2. So in this equation, if you let x equal 3, y equal minus 2, you get minus 2 is 3 times x, which is 3, plus b is 9 plus b. So minus 2 is 9 plus b, so b is minus 11. So we know m and we know b. So y is 3x minus 11. And you can check, this is the equation of the straight line with slope 3, and it passes through the point 3, negative 2. Right? Any questions about that? In the same section in number 47, it asks about the line with x-intercept 2, 0, and y-intercept 0, 3. And it says use the result of problem 46. So in problem 46, you're to prove that if you take the straight line where the x-intercept is a and the y-intercept is b, the equation of the line is x over a plus y over b equals 1. So in this case, a is 2 and y is 3 and b is 3. So the equation of this line is x over 2 plus y over 3 equals 1. And that's the answer to the problem. Right? Any questions? Okay. Let's look at section 1.3. And among the problems were 13 and 17 to 21 odd. So for example, if we look at number 19, we have the function f of x equals 3 over x. So this is defined for all x different from 0. The domain is the set of values for which the function is defined. It's not defined when the denominator is 0, when x is 0, but everywhere else, that's the domain. And if you were to look at the graph of this function, it looks like that. And the range, this is never equal to 0, But the range is also all x not equal to 0. Because if you take any value
Hello?
of...
Oh, my fault. Sorry, I was just trying to make my microphone work.
Take any value of y not equal to 0, y is equal to 3 over x for some x. Let's just say all y different from 0. So this is the domain and this is the range of the function. What about number 21? In 21, we have the function f of x equals the square root of x plus the square root of 1 minus x. And we want to find the domain. So the square root of x has domain all x greater than or equal to 0. Square root of 1 minus x has domain all x such that 1 minus x, what's under the square root sign, is greater than or equal to 0, which is the same as x less than or equal to 1. So on the number line, square root of x is defined for all x greater than or equal to 0. Square root of 1 minus x is defined for all x less than or equal to 1. And the region where they're both defined is in here. So the domain of this function f of x, which is root x plus root 1 minus x, it's all x between 0 and 1. So this interval of x, that's the domain of the function. Also in section 1.3, there is this set of problems 57 to 63 odd. So let's look at number 63. We have the function, let me take a better piece of paper. Section 1.3, number 63, we have the function f of x, which is 3 over x, and the function g of x, which is x squared minus 1. Now we have to look at the composite function, or the two composite functions. So we have the function f composed with g of x. This means f of g of x. For any x, g of x is x squared minus 1. And f of anything is 3 over the anything. So this is 3 over x squared minus 1. So this is the composite function f composed with g. And what is the domain? The domain of f composed with g is all x. The only time there's a problem is when the denominator is 0. So all x such that x squared minus 1 is not 0, which means x squared is not 1, or x not plus or minus 1. So the domain of this function is all x different from plus or minus 1. Right? So you have to know what a composite function is and how to calculate it. And this is the composite f composed with g. There's another composite function, which is g composed with f of x. This means g of f of x. F of x is 3 over x, so that's g of 3 over x. And g of x is x squared minus 1. So g of 3 of x is 3 over x squared minus 1, or 9 over x squared minus 1. And for this function is defined everywhere where x squared is different from 0. So the domain of g composed with f is all x such that x squared is not 0, which means simply x is not 0. So for the function g composed with f, the domain is all non-zero x. For the function f composed with g, it's all x except plus 1 and minus 1. And that's because when you compose two functions, the order in which you compose them makes a difference. Right? There are also some questions in section 1.6. So this is about the exponential function and the logarithm. If you have the function f of x equals e to the x, graph of that function looks like that, going through the point 0, 1. And if you have the logarithm, or for us in calculus is always the natural log, ln of x, the graph of that function looks like that. For the exponential function, the domain is all x, and the range is positive x. For the logarithm, the domain is positive x, and the range is all x. And these are two of the most fundamental functions in mathematics. Let's look at some of the exercises. This is in section 1.6. We want to solve some equations for x. So, for example, number 7, we have the equation 3 to the x is 81. And the solution is x is 4, because if you look at the powers of 3, 3, 9, 27, 81, 3 is 3 to the first power, 9 is 3 to the second power, 27 is 3 cubed, and 81 is 3 to the fourth. So this is the answer. If you look at number 11, we want to solve the equation 1/2 to the x is 32. And in order to solve it, you have to know some arithmetic. First of all, 32 is 2 to the 5th power, and 1/2 to the x means 2 to the negative x. So this equation is the same as 2 to the negative x equals 2 to the 5th. So minus x equals 5, or x equals minus 5. And that's the answer. Let's see. Someone asked if I can do 5 and 7, but in what section? So if your mic isn't working or you're muted, just type it into the chat. Page 10. So in the 5th edition that I have, there's no problems on page 10. So you should tell me what problems it is, what edition of the book you have. But if you don't have the 5th edition, then we're not in sync. But if you can tell me what the problem is, I'll do it. Are these problems in graphing an equation? No. Anyway, happy to do any problem that you can specify, but one linear equation. Page 11. Well, in the calculus book, there's no problems on page 11. But section 1.1, so are you looking at algebra, the algebra class, which it meets at 4 o'clock? So if you're using the book on Blackboard, you're in Math 313, linear algebra, right? It's a different course. So for that course, we meet at 4. Right? Linear algebra meets at 10 and 4. Calculus meets at 9 and 3. Okay, very good. That's fine. Happy to do it then. Does anyone have any calculus problems you would like me to do? No? Limit problems. Okay. So let's look at lesson 2. So this is section 2.2, and there were problems, a number of problems. Let's look at problem 17. So in problem 17, we want to find the limit of 4 minus x as x approaches 3. So this is like we're looking at the function f of x equals 4 minus x, and the book graphs it for us. That's the graph of the function. And when x is equal to 3, y is equal to 1. And if you just look at this, as x approaches 3 from the left, the function is approaching 1. And as x approaches 3 from the right, the function is approaching 1. So this limit is just 4 minus 3, or 1. That's all it is. You see, as x approaches 3, the value of the function approaches 1. That's the intuitive meaning of the limit. Let's look at something more interesting. This is number 19, which is the limit of x minus 2 over x minus 2 as x approaches 2. So that's really very interesting, but what does this function look like? Let's look at a simpler case, just to start. Suppose we take the function f of x equals the absolute value of x. So how is this defined? This is equal to x if x is greater than or equal to 0, and minus x if x is less than 0. So the graph of the absolute value, it's y equal x for x positive, and y equals minus x for x negative. So it's this function, which has like a V-shaped. And suppose you look at the function f of x equal the absolute value of x over x. So what can you say about that? If x is greater than 0, absolute value of x is x. This is x over x or 1. If x equals 0, you get 0 over 0. It's undefined. If x is negative, the absolute value of x is minus x over x, so it's minus 1.
No ves cómo cámara.
Right? Is there a question? No. So for this function, it's equal to 1 when x is positive, minus 1 when x is negative, and it's undefined at 0. And if you look at the function where you replace x by x minus 2, that's exactly the function in the problem. It's the same graph, but shifted over by 2. So for x bigger than 2, it's plus 1. For x less than 2, it's minus 1. And the limit as x goes to 2 of this function, well, if you approach from the right, the limit is 1. If you approach from the left, the limit is minus 1. It's not the same. So this limit does not exist. Okay. So that is the analysis of problem 19. So this is an important thing to understand in calculus, exactly this problem. And any questions about this? Okay, let me do one or two more of these.
Hi.
Yeah, go ahead.
Okay, so for lesson 2 in the syllabus, where it says, do we also have to do the problems that it says review, or that's just for us to practice?
It's just for you to practice, but it's important that you do look at it because we assume you know what's in that section. Now,
Okay.
Right. Yeah.
And so we're just doing the problems that it says 2.2 submit that as homework, but the other ones it's practice for us to do at home, and we look
Correct.
at.
Yes, that's yes.
Okay, thank you.
Sure. Let's do number, let's see, in section 2.2, 13. So this says, determine the limit, if it exists, of the function x to the 4th minus 1 over x to the 6th minus 1 as x goes to 1. And they say do that by making a table. So what they mean by making a table is, well, I guess what they mean is exactly make a table. So for different values of x, you want x close to 1, like it could be 1.1 or 1.01 or 1.001, or points that are just below 1, like 0.99 and so forth. And for each of these numbers, calculate this, see what you get, and see if these numbers seem to be getting close to something. Now, I'm not going to do that because that's just a long calculation with your computer or a calculator. But we'll see shortly another way to do this, and I'll just show you right now. See, when x goes to 1, the numerator and the denominator both go to 1, so you can't like plug in x equal 1, but you might notice you can factor both of these. So for example, x to the 4th minus 1 is x minus 1 times x cubed plus x squared plus x plus 1. That's just a factorization formula. And x to the 6th minus 1 is x minus 1 times x to the 5th plus x to the 4th plus x cubed plus x squared plus x plus 1. In general, there's the following factorization rule from high school algebra. If you have x to the n minus 1, that's always x minus 1 times all the powers from x to the n minus 1 going down till you get to 1. This is this general formula for n equal 4, and this is the formula for n equal 6. So x to the 4th minus 1 over x to the 6th minus 1 is this x cubed plus x squared plus x plus 1 over x to the 5th plus x to the 4th plus x cubed plus x squared plus x plus 1. Because you write it like this and the x minus 1s cancel. And then when you take the limit as x goes to 1, on top, this goes to 1 plus 1 plus 1 plus 1. This goes to 4. And on the bottom, as x goes to 1, this approaches 6. So the answer is 2/3. That's the limit. Let's just look at one more. This is number 23. And in this case, we're asked about the limit as x goes to 1 of the function, which is the cube root of x, times the logarithm, natural log, of the absolute value of x minus 2. And it wants you to compute the limit by looking at the graph of the equation, which it gives you. And this equation, or this function, has a graph which looks like this. And so this function, it's not even defined when x equals 2, but at x equal 1, you can see as x approaches 1 from the left side or from the right side, the value of the function is approaching 0. So the limit is 0. And you get that not by doing any hard calculation, just by looking at the graph. Right here, that's x equal 1. The graph is approaching 0 as x approaches 1 from either side. Any questions about any of these? Okay. So these are problems from lessons 1 and 2. So this is exactly the homework that's due tomorrow. And I can also answer more questions about it tomorrow if at either one of the problem sessions. All right. Any other questions we should do? Again, the lectures for all of this material are on YouTube, and each lecture is an hour and a half or so. And you should be watching 2 lectures a day, so that's about 3 hours for each of the 4 days of the week where we meet. No?
Unless
Sure, happy to do it. Let's take a look. So problem 21, we just have the graph of sine of pi x. So this is the usual oscillating sine wave. All right, that's what the graph looks like. And what happens as x approaches 1? The graph is approaching 0. So the limit as x approaches 1 of sine of pi x equals 0. Right? The graph is just approaching 0 as x approaches 1. So problems where you don't have to do any calculation, you don't really have to do any work, you just look at a graph and read off from the graph the answer. That's like the quickest thing there is to do. You just look and see what's going on and write down the answer. Right. Anything else?